We saw from the part 1 of the Maxwell Boltzmann video the derivation of the most probable speed. Here we're going to recap it and include the two other speeds that we mentioned earlier, which is the average speed and the root mean square speed. The first one is the most probable speed, and this speed is taken by deriving the Maxwell Boltzmann distribution and setting it equal to 0. So what do I mean by that? What it means is taking the derivative of the function with respect to u and equating it to 0. So if you write it down, if you write the whole thing, it will look like d of 4 pi times m over 2 pi kbt raised to 3/2 multiplied by the u square and multiplied by e to the negative mu square divided by 2 kbt over du, equating it to 0. Now if you notice in this equation, this bunch here is a constant, and you'll be deriving only the product of these two terms, which contains the variable. Now the important thing is that after solution and simplifications, we'll be deriving with this equation m u cubed divided by kbt equivalent to 2u, and the further simplification gives us u squared, and this one will be cancelled out, and finally we have u, the speed, which is equivalent to 2 kbt, square root of 2 kbt divided by m. This now represents the most probable speed that we have. Alright, that's the first speed. Now, the average speed. The average speed, u average or u bar, sometimes we use that symbol. This is found by integrating the product of u and the function f of u du. Okay, but I will be showing you the product, the final product of the solution. Now u bar or average speed is square root of 8 kbt over pi m. This is your average speed. Right. And lastly, we have the root mean square speed. Now for the root mean square speed, this is taken by integrating the product of u squared and the function f of u du. The final derivations and solutions of this is equal to square root of 3 kbt over m. This is the root mean square speed. Okay. Therefore, in summary, the three different equations for the three different speeds are, we have the most probable speed equal to 2 kbt over m, the average speed equal to square root of 8 kbt over pi m, and the root mean square speed is equivalent to the square root of 3 kbt over m. And as you notice here, each of these has similar term, kbt over m. Okay, but different integer, square root of 2 here square root of 8 over pi here, and square root of 3 over here. And so if we write it down, and if we take the ratio of these three, what we'll have is that the u of the most probable with respect to u and with respect to the root mean square speed is square root of 2 to square root of 8 over pi square root of 3, or simply 1.13 and 1.23. This is consistent to what we saw earlier in the graph when I showed you the curve representing the function. We saw that here this represents the most probable speed, and right here, slightly on its right, is what we have the average, and slightly further that right is what we have here, is what we call the root mean square speed. So these three speeds represent the overall movement of a sample of a gas as a function of temperature.